Hi team, so today we're looking at direct proof and proof in general. So I'm going to prove you something that is totally untrue, and you're going to try and spot the flaw. So I'm going to prove that $1 is really just 1 cent. This is going to be great if you ever owe someone $100. If you can pull off to them that $100 is really 10 cents or 100 cents, sorry, you are going to be in a very good spot. So let's start with what we know. I know that $1 is the same thing as 100 cents. I know that as a fact, but that's great, but it's not really what I want to prove. In fact, it's kind of the opposite. So let's go from here. I also know 100 cents is really, well, 10 cents all squared. All right, 10 squared is 100. Yep, that looks good. Second step, okay, well, I can write 10 cents as $0.10. Keep the squaring because we had it before. Well, 0.1 squared is 0.01. So if I have $0.01, that's really 1 cent. I have just proven to you $1 equals 1 cent. So if you spot the flaw, you know what it is. Post that in the comment section below. Now we'll do some actual proving. So 3 types of proofs: direct proofs, contradiction, and induction are the ones we're going to focus on because they're the ones that help us with things like geometry proofs, vector proofs, and proof by induction is in university, not necessarily in school, so we can have a look at that as well. First type, 8a, direct proofs. So we have a statement. For instance, if a is an odd integer and b is an even integer, then a plus b is odd. Our job is to say, okay, well, if the first part of this statement is true, I have to prove the second statement is also true. So we call the first part of the statement P, the second part Q. We identify what P and Q are using mathematical notation as best as we can. Assume P is true, and using this prove that Q is also true. And then we write a conclusion in words. So there are our 3 steps. Let's have a go at an example together. So like I said before, we're going to pretend that a is an odd integer, b is an even integer, and then prove a plus b is odd. So first we have to identify what is p in this statement. Well, p is always the thing that comes before the then. Let's write it mathematically. So if a is odd, I could write that as 2m plus 1. If it's an integer, remember that m would have to be an integer here. So for instance, 2 times 7 plus 1, well, that's 14 plus 1, 15. That's an odd number. It's also an integer. If I let m be something else, like, I don't know, 0.25, not an integer, we're not going to end up with an odd number there. So just make sure you include that m is within integers. If b is even, I could write this as 2n. Again, n within z. And remember that the m and the n here might not be the same, so I use different variables in this case. Then let's see, what is our q? Well, q is this part. A plus b is odd. So q, we need to prove that a plus b is odd. So again, I could say that has a form of something like 2p plus 1, where p is just some number within our integers. That's step 1. Step 2, we're going to take P, everything that we know about P, our A and B, and try and write those things in a form like Q. If we can do that, we've proven it. So using P, what is A plus B? Well, A was 2m plus 1. Oh, sorry about my screen. Plus B, well, B is 2m. Okay, that doesn't quite look like the form that I've got for Q, but I can help. Maybe let's take the 2 out the front of the m and m. I'll get 2m plus n plus 1. Now notice, these look exactly the same. A plus b equals 2 times some number m plus n plus 1. Notice also that if m is an integer and n is an integer that we've got at the top, m plus n must also be an integer. So this is really of the form 2p plus 1, where m plus n equals p, and that's within Z. And I have just proven, therefore, if A is odd integer, and I'm just doing it shorthand, B is even, you need to write it out in full, then it's true that A plus B is odd. And we're done our proof. I'm going to go through one more example with you. Here it is. Given that n is an even integer, we need to prove n squared minus 6n plus 5 is odd. All right, first step, find your p. N is an even integer. That's the first part of our problem. So I could write this as n equals 2m, m is within z. Okay, so that's just saying n is an even whole number. Then I've got to prove that q is true. So that n squared minus 6n plus 5 is odd. I could let the odd part be, again, maybe 2p plus 1, where p is within z. So let's have a look at our p and try and do something to it so we can have our q. N equals 2m. Okay, well, why don't I just let n squared minus 6n plus 5 and see what that looks like using our p fact that n is 2m. So I'm just going to substitute the 2m inside. So I have 2m squared minus 6 times 2m plus 5. Okay, right now, that does not look like my q. But maybe I can get a 1 hanging off the end and a 2 out the front of something. To get the 1 hanging off the end, let's expand 4. 4m squared minus 12m plus 5. Again, doesn't look anything like that q. But I could get a plus 1 off the end by making that plus 5 into plus 4 and plus 1. I'll get something like this. And I think this is pretty cool. Plus 4, plus 1. Okay, I've got the 1 hanging off the end here. I also need a 2 out the front. So let's take that 4m squared minus 12m plus 4. Take a 2 out the front of that. I would get 2 brackets 2m squared minus 6m plus 2 plus 1. And look at what we have. We have 2 times some number, p, plus 1. The only thing you've got to make sure is that this 2m squared minus 6m plus 2 is still an integer, like the form that p is. So 2 times m is an integer squared, that will give me an integer. Minus 6 times m, integer, give me an integer, plus 2, well, that's an integer, I'm going to get an integer. So this is really of the form 2p plus 1, where p is equal to 2m squared minus 6m plus 2, and that is within z. So we've just shown that n squared minus 6n plus 5 is indeed odd if n is an even integer. So that's your conclusion. So n is even integer. It is true that n squared minus 6n plus 5 is odd. Okay, what next? So after you've watched this, maybe take some notes on it. Thursday, at 12 o'clock, we're all going to come in as a team onto our live video link. I'll make sure I'll invite each of you at this time. We're going to go through 2 examples as a class. I'm going to show you my screen. You're going to write notes, but that's a great time to answer and ask questions about the examples. Then I'm going to give you a last question to try by yourselves. And then again, you can discuss it, see if you need help. And then after that, you'll go on with 8A and I'll upload that to the OneNote. All right, awesome. Have a great day.